A non-directional beacon is an AM radio station used for aircraft navigation. The automatic direction finder, ADF, inside the airplane receives the NDB signal. The ADF needle simply points toward the selected NDB station, providing the pilot with a bearing to the station. Commercial AM radio stations may also be tuned and received with the ADF. As with the VOR, select the appropriate frequency and configure the airplane's audio system so that the NDB's Morse code identifier is audible. Each NDB has a unique 2- or 3-letter identifier. Since the ADF has no flag to indicate reception of the NDB, the pilot must continuously monitor the Morse code identifier whenever the NDB station is being used. The ADF needle points directly towards the NDB, displaying the bearing relative to the nose of the airplane. This relative bearing is simply the angular difference between the nose of the airplane and the station's location. Turning the airplane until the needle is pointing directly ahead results in the airplane being pointed directly at the station. The magnetic bearing is much of the time a more usable number since it tells you what the magnetic direction to the station is from the airplane. To find the magnetic bearing, add the airplane's heading to the relative bearing displayed on the ADF needle. For example, if the ADF needle showed a relative bearing of 150 degrees and the airplane was on a 030 heading, then the magnetic bearing to the station is 180 degrees. This means a 180-degree heading would point the airplane at the NDB, so the NDB is south of the airplane. Adding or subtracting 180 degrees from the magnetic bearing to the NDB gives the magnetic bearing from the station. In our example, 180 plus 180 gives us 360 degrees from the station. This means the airplane is north of the station. Most pilots memorize a formula to aid them in learning to use NDBs. MH plus RB equals MB, or magnetic heading plus relative bearing equals magnetic bearing. To fly directly toward an NDB, first turn the airplane so the needle is pointing straight ahead. The airplane is now pointing directly at the NDB. Just like with VOR navigation, the airplane will soon drift off course without proper crosswind correction. The process is the same, the pilot only needs to understand the different display of information. Maintain your heading and observe the movement of the needle. If the needle moves right or left, you will have to turn your airplane right or left to stop the airplane from drifting off course with the wind. For example, let's say the needle moves 5 degrees to the right. We must turn right to correct for this, so we turn 15 degrees to the right. Since the ADF needle always points directly at the station, it is now pointing 10 degrees to the left. The tricky part is to realize that we want the needle to show an angle equal to our wind correction. Since we turned 15 degrees to the right, the needle should show 15 degrees to the left of our nose. At the moment, it shows 10 degrees left. Maintain this setting and watch the needle for a few moments. Let's say the needle continues to move to the right, and now it shows 5 degrees left of course. This is an indication that we're still drifting. A greater course correction is required. We turn another 15 degrees to the right, so now our total wind correction is 30 degrees to the right. So we want the ADF needle to show 30 degrees to the left. It shows 20 degrees left at the moment. Maintain this heading and wait. After a few moments, the needle begins to move to the left. When it shows 30 degrees to the left, we're back on our original bearing to the station. At this point, we know that 30 degrees is too much wind correction and 15 is too little. We elect to turn 10 degrees back to the left, which will leave us a 20-degree right wind correction. The ADF needle points 20 degrees left of course, and that's right where we want it. Maintain this heading and wait. Continue bracketing until you find a heading where the ADF needle does not move left or right, and make corrections as necessary. To fly directly away from an NDB, first turn the airplane until the tail of the ADF needle is pointing directly ahead. The airplane is now pointing directly away from the station, but drifting with the wind. Search for the wind correction angle by maintaining different headings and bracketing as before. Area navigation systems allow pilots to fly directly to particular points over long distances. Some RNAV systems use signals received from VOR DME transmitters and a processor to provide the pilot with a direct route to the selected point. The Global Positioning System, GPS, is now widely used for area navigation. GPS consists of 24 satellites, 5 of which are observable at any time from anywhere on the planet. 4 satellites are necessary for a GPS receiver to yield a 3-dimensional position. The GPS receiver compares distances from orbiting satellites to calculate the airplane's position, and the display allows for the direct navigation to a specific point.